With Regal's Phoenix chipset and UltraVision 2 technology, this allows these series of digital oscilloscopes to come equipped with 7 instruments in one, including a 4-channel analog scope, 16-channel logic analyzer, 2-channel waveform generator, digital voltmeter, counter and totalizer, an FFT spectrum display, and a protocol analyzer. These instruments come equipped with a 2-channel waveform generator built into the instrument, which allows you to create your standard waveforms, which include a sine wave, square wave, ramp, pulse, DC, and noise functions. Then there are also a handful of built-in arbitrary functions, including a sync function, and we can load our own arbitrary functions by selecting the arb at the bottom. Let's select our sync function here, and we'll now see a sync function on our oscilloscope. Let's move this so we can see 2 points. And now we can also change our frequency, the amplitude, offset, start phase, align phase, all that. And then if we wanted to, we can then go into our settings, and then we can go into type, and we can choose if we want to modulate the signal, sweep the signal, or burst the signal, if we would so desire. Let's go back to source 1. Now to show some of the other capabilities of the instrument, let's turn on our second generator, which will now see a sine wave on channel 2 in blue. And what we're going to do here is we're going to select our waveform. We're going to actually go all the way down, and we're going to select arbitrary. And then from here, this is where you can load a stored channel if you have a flash drive. You can create a function or edit one. Or you can load one from a channel. So let's say load channel 1 on the channel 2. So load the sync function in yellow onto channel 2 in blue. And then we can choose either screen or cursor data. So let's go with cursor. And what we'll do is we'll set our 2 cursors to be at the peaks on our sync function. And then once we've done that, let's get this, we'll press load, and this will now load a sync function on the channel 2. And this can be rather useful for either doing more analysis on a signal that you're capturing with your oscilloscope, or if you just want to reproduce a glitch you've seen. These instruments come with a built-in digital voltmeter, which can allow you to easily measure the voltage of your signal. And to access this, you can either do it through the quick access menu on the touchscreen, and then click DVM, or you can go through the measure button in the measure menu, and then go to analyze, and then press DVM as well. And this will bring you to your digital voltmeter measurement menu. And this can allow you to select your source, your mode, and your limits. And let's turn it on. And what we'll see here is, we can drag this on our screen. We'll actually see it's now showing roughly 50 millivolts for our channel 1 signal. The frequency counter and totalizer allows us to easily be able to measure the frequency response of a signal or count up the total number of trigger points that have occurred on a signal. To access it, you can either go through your quick access touchscreen menu by pressing down at the lower part of the corner, and then you can press on counter, or you can go through the measurement menu, and then you can press counter here. And this will bring you to your frequency counter and totalizer menu. And once you've turned it on, so we'll now turn it on, we'll see it's displaying the frequency of channel 1, and we can change this to be one of our other channels. And then we can also change our measurement type to be either frequency, the period, or count up, or the totalizer, which is really just counting up the total number of trigger events that have occurred. These instruments all come equipped with an FFT spectrum display mode, which allows you to easily view a signal not only in a time domain, being shown here normally in yellow, but also in a frequency domain. In order to access this, you can do this through the quick touch menu at the bottom by pressing that and then FFT, or you can press math, and then your math channel you wish to use, and then your operator. You can then select FFT. And then within here, we're able to select our source, and we can turn it on. And what we'll see here is we'll start to see a frequency response of the signal. So let's go ahead and dive into this a little bit more. Let's now go into more, and let's change our scaling. We're looking at a 1 megahertz square wave, so we don't need to go up to 500 megahertz. We can in fact change this. Let's go to 10 megahertz. And we'll see, if I exile this, we'll see our main signal and then our multiple odd harmonics afterwards. Let's turn our menu back on. And within here we can easily then change our offset and scaling if we wish. And if we go into more, we're able to change our scaling as I already showed you. And we can also say, let's go zoom this out a little bit by changing our horizontal display. We're changing our RBW setting down here in the bottom as we scale out a bit. But we can now go into our peak search, which this can allow you to easily then find multiple peaks. So in order to do that, you first turn it on, then you go threshold, and then you're basically saying a trigger point with this dotted purple line. And once it's below, you'll actually see your 5 peaks that are being displayed on the screen. You can also then go back in the options and then press more, and you can actually add a color view, which basically shows you your probability of each sort of frequency for the signal, which is another useful aspect that is normally only available with spectrum analyzers, but is also available on your oscilloscope as well. These instruments are also equipped with a 16-channel logic analyzer. In order to activate this, you first press the LA button, or you can press the L button at the bottom of the touchscreen, and then you are shown 16 digital channels at once. Once you're within the LA menu, you can then go into the on-off section, and you can say turn off a full bank, or you can turn them off individually as you so desire. Let's turn off D8 through D15. Once I've done that, I can now actually group my channels together. So I already know that D7 and D6 are part of an I2C bus, so I'm going to group them together by going into Group, and then Group 1, and I'm now going to select D7 and D6. And I've grouped those together, and then we'll press back, and then to turn those on, I'm now going to press Group On-Off. I'm just going to turn them on. We'll now see them grouped together now in orange, which is an easy way to distinguish them from the other 6 digital channels that were now being shown on the screen. Once we've done that, we can go back, and we can change our thresholds if we so desire. We can change our arrangement, either if we want D0 on bottom or on top. And then we can also change our size, either medium, small, or large. Let's choose large, just so it fills the entire display. And then we can also label them together. So within the label menu, we can turn them on, and we'll now see labels appear on the left-hand side of our screen. We can select our channels. Let's choose D7, which happens to be a clock channel, and we'll go into our library, and we'll label it as a clock channel. And then if we select D6 to be our data channel, and once again label as our data channel, we'll now see clock and data being labeled on our orange signals, which is another easy way to distinguish the multiple channels together, allowing you to, at a glance, distinguish which digital channels are for which particular aspect. Protocol analysis is a useful tool to easily decode serial communication. To do that, you can either use the quick access menu and then press decode, or you can press the decode button on the oscilloscope, and then you can decode up to 4 different buses at once. We're just going to choose decode 1. And then from here we can choose our type. We're currently looking at an I2C signal, so we're going to go ahead and select I2C. And then I've already set up the triggers so that we're triggering on our signal. So I will now just copy the trigger over, and this will copy over, basically set up that D7 is clock and D6 is data, just to associate with these 2 lower signals. And now once I've done that, I can turn the bus on. And we'll now start to start to display a decoded signal. And within this, I can now press display, and I can change our format. Currently we're looking at it in hex, but we can change that to say ASCII. And we'll see it read regal across the screen. Let's actually change our scaling a little bit on that, just so it's a little easier to read. And now within here, we can then view our data this way. We can also use our event table. And let's scale out a little bit, and we'll now see quite a few different decode events. We'll turn our event table on, and we'll see it start to decode our data, and we can also change our format from hex to ASCII as well. We have our same different formats. And then we have a couple different views. We can view the signal either in packet form, detail, or a payload form. So let's actually jump over to payload real quick. And this allows us to see all the data on the screen being decoded all at once, which is a great way to view really long streams of data where you can't actually see it in green on the screen, but now you can see it in the event table. We can also then, if we hit stop our oscilloscope and press the stop run button, we can then press on packet, and now we can see it all in correlation to our trigger event in terms of time, but we can also see it's a read-write packet and then the address of where it's going to and the data, and if it was acknowledged or not. And we can say go ahead and select one, so let's go ahead and select the third one down, and then we can press jump to. And within this, we'll actually move on the oscilloscope our trigger point, so we've actually jumped to that packet, so that, say we then exit our event table, we can then change our scaling in and further view it, which is an easy way to move around on long serial communication data to allow you to see if there's any parts of your signal that have errors, and once you find one, easily basically view it on the screen and see if there's any problems with the actual bits themselves, or if it's something else that might be causing it. With the 7 built-in instruments in one, all powered by the Phoenix chipset and UltraVision 2 technology, these oscilloscopes are powerful tools for any engineer. If you have any questions about these products or family of products, please contact us at Regal or visit regalna.com for more details.